Thank you so much.
Of course, thank you, Roberto, and thanks. It's obviously lovely to see you yourself, and it's really nice to be here. So, as I was saying to you, my presentation is perhaps not as technical as some of the previous ones, but I hope just to introduce everybody to some Irish soils and to some work that's ongoing here in Dublin. So my name is Mike Long, and I'm a geotechnical engineer. Work here in University College Dublin in Ireland, and my research topic has been on the characterization of natural soils. So looking at the properties of natural soils, using in situ tests and lab tests, and then applying that work to real life problems. This presentation here is together with our conference chair, Roberto. Roberto was a research scientist here in UCD for 1.5 years and did some really nice work. So this work I'm presenting is also his. And we worked together with a consulting company called Arup. And the project was on the long term, or the project is, it's an ongoing project. The project is on the long-term geotechnical performance of earthwork slopes in Irish glacial tills. Okay, I hope I can make this slide go to the next one. Okay, thank you. Our client in this project is the Irish Transport Infrastructure Ireland, who are the Irish body in charge of all of the main roads and railways in Ireland. And TII, together with many other similar organizations throughout the world, face significant challenges with respect to the long-term maintenance of their highway networks. And they're obviously concerned with long-term weather effects and with climate change. So what they asked us to do was to investigate and to monitor the geotechnical behavior of one cut and one embankment on the Irish motorway network. In this presentation here, I'm going to focus on cut slopes. Embankments are perhaps a job for another day. Now, this is a topic that has been researched in other places, and I'm sure many of you are familiar with that. Perhaps the most notably in the UK, there has been two significant research projects called ISMART and Achilles, which have similar objectives to this study. But those studies both were dealing with the UK soils, which are very different from the Irish soils that we're dealing with here. So this slide is from the Achilles project, from one of the publications on the UK Achilles project. And what it shows on the y-axis is the performance of a geotechnical asset, and on the x-axis it shows the age of the geotechnical asset. And if you follow the graph from left to right, you will see that we're following the blue line here. You will see that initially there's a period where the asset's very new and it's bedding in, and its performance is improving with time, and then it reaches a plateau, and perhaps for a long time, the performance of the asset is very reliable. But then some time will come eventually when the performance of the asset begins to deteriorate, and eventually it will become unreliable. What I'm focusing on here, and what our research focused on was the period of deterioration. So what causes the deterioration in the particular assets that I'm talking about here? So this is, excuse me, this is a geological image of Ireland. You can see, if you focus first of all on the image on the left-hand side, this is Ireland here. Dublin is located here on the east coast. There's a lot of detail on the slide, but if you focus on maybe on the brown colours on the left-hand side, and these are glacial lodgement tills. So these are materials which were laid down underneath the glaciers during the retreat of the glaciers in the last ice age some 10,000 years ago. And you can see these brown colours dominate the country. So these glacial lodgement tills are of significant importance. On the right-hand image, you can see two colours. The green colours refer to these glacial tills, which are derived from limestones, and the orange colours derive from glacial tills, which are derived from sandstones and shales. And you can see that And the motorway network, or the national road network, is shown by the red lines. And you can see that these glacial tills are of significant importance with respect to the road network. So the research site that we chose, based on a lot of very nice work by Roberto, is located where you can see the black dot. It's located near a town called Castleblaney in the north of Ireland, and it's on a road called the N2. So this is the slope that we're interested in. This is a really classical Irish slope. You can see that the road, which is in this case is a 2+1 motorway, has been cut into the hillside here. And in Ireland, the standard practice is to use a cutting of 1-on-2, so 1 vertical to 2 horizontal. Perhaps a little bit conservative, but that's what's used. And this slope is about 8 meters high. And you can see one of the nice things about this slope is that there's a nice access road at the top of the slope, which allows us access to the top of the slope. So I think this slope is a good choice. It's characteristic of the soils in Ireland, and it's characteristic of the construction techniques used in Ireland and in other places. So just to get into some details of the soils here, and perhaps maybe to show why they're a little bit different from soils you find in other places. So this is a particle size distribution curve, which shows the percentage passing, a sieve on the y-axis and the particle sizes on the x-axis. The blue lines are from our site. And you can see that the lines form an approximate straight line relationship. And this is a classical, what's called in geological terms, is called a diamicton, a glacial till, where you get this very linear graph of percentage passing versus particle size. So there's a large range of particles involved, and this is why these materials can compact very well. I'm going to compare these soils to a well-known soil called Dublin boulder clay, which is the soils which are underneath my feet at the moment here in Dublin, and these soils have been very well characterized. You can see our soils, the blue curves, are a little bit coarser than the Dublin boulder clay, but they're broadly very similar. We like to use basic index properties to characterize our soils. And here you can see the water content on the far left-hand side from the N2 site. The water content is some 10%, so it's a relatively low water content. Again, the plasticity index is also relatively low, about 8% on average. And on the far right is the liquidity index. Liquidity index is equal to the water content minus the plastic limit divided by the plasticity index, is always negative, so maybe typically minus 0.8. And this tells us that this is a very competent glacial material, and it's likely to be very heavily over-consolidated. So these materials are excellent, provided you leave them alone, provided you protect them, and provided you don't expose them to weather changes. So this is a picture from a site very close to where I live in Dublin, and here the developer dug a very deep, relatively deep, 6-meter deep, steep cutting into the Dublin boulder clay. Of course, what he was trying to do here was maximize the number of apartments he could fit into this site. But you can see here that the material is standing at approximately 90 degrees, and it stood there at the steep angle for a relatively long time before a retaining wall was built in front of it. It was a brave piece of operation because he was cutting right next to his neighbours there, just behind the cutting. So these materials are well known to be able to stand unsupported for significant long periods. And of course, what's allowing this to happen is that when the excavation happens, some suctions are induced into this material. And because it's so low permeability, these suctions can be sustained for a long period, allowing these materials to stand up. However, this is not a stable situation, and weather-induced and climate-induced effects are going to change this rapidly. So the fact that these soils can stand unsupported for significant periods of time was used by engineers in a constructive way during the construction of a large tunnel project here in Dublin called the Dublin Port Tunnel. This tunnel is just north of the city on the road to the airport. It's on the M1 motorway, which is the road between Dublin and Belfast, and passes by the airport. The contractors were forced to divert the traffic on the M1 to both sides of this cutting during the construction process. And in order to facilitate this, they cut a very deep excavation, probably 12 meters high or so, at 70 degrees into these glacial till materials. And this was a significant project, was approximately 1.2 kilometers long. It's called cut and cover construction. So ultimately, the tunnel was built and the whole area was covered. Some soil nailing was used to reinforce the slope, but broadly speaking, the ability of the soils to stand unsupported was used in the technique. Now we had to impress to the client that this technique would work. So here is a picture of a trial trench that we dug prior to the main works. This mimics the main works in that it's about 12 meters deep. The material is cut at an angle of 70 degrees, and you can see that there's some protection measures applied to the exposed material here. Plastic sheathing on one side, some shotcrete, some sprayed concrete on the other, and there's also a few trials of some soil nails done. So using this trial, we were able to demonstrate that this technique would actually work in practice. And again, just on suctions, and this is something that we've done really just for our own sake, just in order to try to get a feel for what's the variation of these suctions in the Irish glacial tills with time. Now, this is not a cutting, this is an embankment. It's an embankment in a hydroelectric scheme on the River Erne in the north of Ireland. And again, it's a relatively long embankment, 6 or 8 meters high. And it's made of glacial till material, very similar to the ones I've just been talking about. And we put some tensiometers into the embankment here. And these are just agricultural style tensiometers, can measure suctions up to maybe minus 100 kilopascals. And we really wanted to see what was happening over the year, so everybody knew, everybody could understand what was going on with these materials. And I've just taken a snapshot here of data for 6 months. And what I want you to focus on here is the blue dots. So these are the tensiometer suction readings, and suction is shown on the y-axis and time is on the x-axis. And you can see that the values vary between small positive values, plus or minus 2 maybe, to minus 10 or so kilopascals. And if I'd shown all the data, and I haven't shown it here because I didn't want to confuse everybody, you can see that over a period of years, the suctions will cycle between plus 2 maybe and minus 10 in 6 monthly intervals. So I suppose the question is, what is the long-term effects of this cycling of the suctions going to be, and how is it going to affect the geotechnical assets? And that's really what we want to find out in this project. So what you will see is something like this. This is a temporary slope. Again, in a construction project, the slope is, in this case, perhaps 5-6 meters high, was cut very steeply into the glacial till materials, was left unprotected for a period of time. And again, you can see that there's a gradual deterioration in the slope. And this is due to weather-induced changes. So the suctions that were developed have been eliminated by the weather here. And what you see then is the slope deteriorates and the material slides off in relatively small wedges. Now here the consequences weren't significant because it was just an access road to a construction site, but it does indicate that this is what could happen to these geotechnical assets, in the long term if they're not carefully looked after. This is a similar cutting. This is actually in Dublin Airport, if any of you have been there. This was an excavation for an underground baggage handling facility. The contractor cut a very steep slope in the Dublin boulder clay here, trafficked up and down adjacent to it with trucks, as you can see. And the suctions, again, diminished over time. And due to the lack of suction and due to the loading that was applied, you got, again, shallow failures. We would call them flakes in English. So it's like you get these shallow slides sloughing off the surface of the embankments here. So this is what's happened. And this, of course, is what we want to guard against with the motorway network. And just going back to my trial trench. So this was the trial trench for the Dublin Port Tunnel. And there was one section of the trial trench where the contractor encountered a small granular lens. And of course, the effect of the granular lens was to allow rapid release of the suctions which had been induced. And that release of suctions allowed the effective stresses to reduce, and therefore the strength reduced, and you got a failure like this. And again, what you see is you don't see a very deep failure like you might see in a soft clay material, but you see a relatively shallow wedge-like portion of the soil sliding off the face of the embankment. Of the cutting in this case. So with all these things in mind, we've gone on to make a plan for the work that we're going to do on our project site. So this work is ongoing, and maybe this time next year I can come back and maybe give you some of the results of what's happening on the site. So as I explained, we have access to the site due to a nice access road at the top here, and we intend to install 2 boreholes, and we're going to take cores of the material. We're going to use a GeoBore-S coring technique. This is a triple tube coring technique, which is very suitable for these very hard glacial tills, which have a high stone content. So we're going to get some GeoBore-S cores, which of course we will test in the lab. In one of these 2 boreholes, we're going to install an inclinometer to look at the lateral movement of the slope in the long term. And then the other, we're going to install some piezometers. And these piezometers will have a suction measuring device, because I think you can see that suctions are key here, and we're keen to understand what's happening to them in the long term. On the surface of the cutting, we're going to install some shallow suction measuring instruments. And we're also going to install some instruments with which we can monitor the volumetric water content changes in the slope. We're going to try to use satellite monitoring, has been the case in several of the presentations at this conference so far, and we're going to mount some surface mounted reflective targets to help the satellite monitoring, and of course we're going to have a weather station as well. So the next steps in this project are to drill these boreholes and do the samples and install the instruments as I explained. And then we plan to monitor the slope for as long a period as is possible. But in parallel with that monitoring, we intend to develop a numerical model, and Roberto has done a lot of work on this and has published actually some papers on the suggested numerical models which might be appropriate for this work. Then the idea is to try to match the model with the monitoring we get from the instruments on the slope. And of course, the ultimate objective is to attempt to apply these lessons widely to the Irish motorway network. And our hope is that our clients, Transport Infrastructure Ireland, will be able to make some better plans about their asset management and on their maintenance scheduling into the future. So that's all I have to say. Thank you very much for listening. I'm obviously happy to take questions. And Roberto, you probably know more about this project than I do, so especially the modelling side. So I'm not sure if you wanted to add anything to that.